Guys, so it's now time to start playing around with some new trig identities. Now, if you've been playing along with the playlist, I've mentioned these guys in previous videos. In this one, we're going to prove them, and in the next one, or couple, however many it takes, we are going to play around with using them to simplify trigonometric expressions. So, here are our two new identities then. Tan of theta is sine theta over cos theta, and sine squared of theta plus cos squared of theta is equal to 1. So, first up, let's prove that tan theta is equal to sine theta over cos theta. So, to prove this, we need our SOHCAHTOA identities. So, SOHCAHTOA tells us sine theta is the opposite over the hypotenuse, cos theta is the adjacent over the hypotenuse, and tan of theta is the opposite over the adjacent. So, if tan of theta is equal to sine of theta over cos of theta, then sine of theta over cos of theta will equal the opposite over the adjacent. So, let's do that and see what happens. So, sine of theta over cos of theta, well, that's the opposite over the hypotenuse divided by the adjacent over the hypotenuse. Now remember, when you divide by a fraction, you flip it over and multiply by it. So this is actually the opposite over the hypotenuse times the hypotenuse over the adjacent. So what happens there, the h on top and bottom cancels out, it's a common factor, and we do indeed get the opposite over the adjacent. Therefore, tan of theta is indeed, now we compare an identity sign here, because it is identical to sine of theta over cos of theta. QED. We've proven it. Good times. Okay, now to prove sine squared plus cos squared is equal to 1, we need our old friend, the unit circle. So remember on this guy, what we do, we draw a line out or a radius out from the centre of the circle. It's the unit circle, so this is going to have a length of 1. The angle between that radius and the positive x-axis is theta, and then if we draw a vertical line down and a horizontal line across to meet that, then we can do some cheeky SOHCAHTOA. So, to angle theta, the vertical line is the opposite, and the horizontal line is the adjacent. So, we know from SOHCAHTOA, sine of theta is the opposite divided by the hypotenuse. So, the opposite divided by 1 here. Therefore, the opposite is actually sine theta. So, let's change colour. So this side here is actually, let's get rid of the O, sine of theta. And then if we do something very similar for the adjacent, well, we know that cos of theta is equal to the adjacent divided by the hypotenuse. So here That's the adjacent divided by 1. Therefore, the adjacent is cos theta. So, if we zoom in on this side, let's get rid of the A. We know then that that side is actually cos theta. So let's take that triangle out on its own to make things a bit clearer. So we've now got a right angle triangle, or we would do if I could draw. So we've now got a right angle triangle with a hypotenuse of 1, a length cos theta, and a height sine of theta. So, what do we like to play inside of right angle triangles? Pythagoras. So if we call this side A, this side B, and the hypotenuse C, then Pythagoras tells us A squared plus B squared is equal to C squared. So, we get sine squared theta plus cos squared theta is indeed equal to 1. Now you can write that as an identity as well, because it's always true. There we go, guys. Quite enough done. We've proven our 2 trig identities. So in the next video, we're going to take a look at using these guys to simplify trigonometric expressions. Good times.